Hello, today I want to talk to you about buttons and external inputs. So what is a button in electronics? It's basically a device in which whenever you press it, the current flows. It's like a switch. Now, the problem with a button is that when you actually press this button, you think that it is going to switch between 1 and 0 smoothly, but in reality this transition is followed by a ringing, because internally the button has a sort of metallic slab which oscillates owing to the mass, and it causes this ringing here. This ringing here is called the bouncing effect. So you want correctly to send a signal, the button signal, you want it to send smoothly to a microcontroller. So how can you do that? Well, basically there are several techniques. The first technique is called the SR circuit. So basically you have the voltage VDD, and what you're gonna do is to use an SR latch. This is a very complex technique, and you connect the reset to a pull down coming with a signal. So basically when the latch goes to 1, it means that in the first moment that the switch is closed, the output goes to 1, Q goes to 1, and since it is a latch, it will stay. The output will be latched and fixed to 1, and this stays to 1 until the reset, until someone applies a signal to the reset. But this is a very complex solution, and it is not so easy to be applied. Another solution is to put a buffer. So basically you have always the voltage, let's call it VDD, you have the switch, and just you put just a buffer which will loop with a resistor, and will create this is a non-inverting CMOS, and will create a loop to stabilize the output. The solution that I'm going to show you is to put an RC plus a Smith trigger solution. So you have always a voltage VDD, you have a resistor R, which is a pull-up resistor with orders of 10 kiloohms, 100 kiloohms, whatever, and then you have the RC net, or RC pass filter, whatever you want, and this goes directly into a Smith trigger, so that the output basically will be smoothed by the RC, lowering drastically the ringing effect. You can even think to connect the button like this for simplicity, and will still work. So you have a voltage V, you have a pull-up resistor, R pull, you connect the button here, and here you will connect a low-pass filter net. This connection will still work, so that you have square wave here, and you're gonna have something like this. Now follow me into the lab, and I will show you how it is made. Okay, so basically here I connected a button with a pull-up resistor, as I showed you. There is the voltage connected to 5 volts. So whenever I'm pressing the button here, you expect to have 5 volts. and as you can see, there is 5 volts. It is very, very, very noisy, just because also I'm moving my finger here. If I move my finger, you see that the noise is coming from the contact of the button. But if I press very, very fast, it would be like a series of pulses. Still noisy. So what you're gonna do to avoid all this noise is to put an RC filter. Let's just put a resistor. Give me just a second. I will put 10 nano and 50 kilo ohms, and let's see how it goes. Okay, so I put my low pass filter exactly here, and let's read the output voltage. So as you can see, if I press very, very fast, you see that there is not any more square wave, because now it is filtered by low pass filter, and if I press correctly, you will have a less noisy waveform, exactly as you expected. Now this is just a random value of a low pass filter, but all the noise that were before is at least a bit filtered. If I still continue to damage the circuit, naturally there will be some noise. But let's avoid this and imagine that this will be on a printed circuit, so this solution is still going to work. You see that the smooth transition at the end. Now I didn't design the smooth trigger, but you can understand that this button is almost broken, but it actually does the job.